Namaste friends, this is Professor Makarand Upkare with you for Computational Techniques in Engineering and Sciences. This is an important subject in engineering or the sciences field to know which are computational techniques are used in the field of various engineering streams like chemical engineering, mechanical engineering, civil engineering, or in physics, chemistry, biology, astrophysics, so on and so forth. So what are the computational techniques? Imagine you have a process. A simple mixer is mixing two streams to form a one stream, where two miscible liquids are coming in to form a homogeneous liquid coming out of the mixer. Now this is a simple mixer is a process, but when you describe this process in terms of mathematical equation, it forms an equation that is called as modeling. When you convert all the process equipments into equations, it forms a system of equation. The same is true for mechanical engineering, civil engineering, or in physics, biology, or astrophysics, where a large number of equations are derived based on the underlying study. These equations can be solved, of course, by pen and paper, but more efficiently using the computational techniques, using the computers. When we say computational techniques, there are two ways that we are going to see. One is we are going to see different types of open source softwares, like we will be seeing Scilab or GLN or some other open source software, and we will see also a programming language that is Python. Now you know that my bias towards Python. Python is an extremely simple programming language, zero learning curve there. Anybody who can eat can code in Python. That's what I firmly believe in. And there are phenomenal libraries in Python like NumPy, SciPy, Matplotlib, so on and so forth to help you navigate through the computational techniques and the graphing. Now, which all techniques generally they are used by the engineers or the scientists? So the first is we'll come across the algebraic equations. So in chemical engineering, when you are doing mass balance, energy balance, writing a simple heat equation for the heat exchanger, so on and so forth, it will form an algebraic equation or a system of algebraic equations, right? So we need to solve these algebraic equations. The other type of equations you will come across, they are the polynomials. Like when you have the ideal gas law or van der Waals equations, or in case of mechanical engineering, the string theory, or in physics or chemistry, you will have various polynomials in one or more degrees, polynomials which are in the single variable or multiple variables. Then we come to very important topic of ordinary differential equations. What is a differential equation? Differential means when one variable is changing with respect to another variable, most likely that changes with respect to time. So you will have dx by dt, dy by dt, or dc by dt, so on and so forth. So that is called as differential equation. Hardly the life comes with one differential equation. Most of the systems will have large number of differential equations. That is called as a system of ODEs, and we will learn to solve this one ODE, that is single differential equation, or system of ODEs, that is many number of differential equations in a series. Then we come to the linear and non-linear equations. So linear and non-linear equations and solution of these non-linear equations is quite tricky, but very useful and easy when you utilize the softwares and the programming language. Next we come to the topic of optimization. You know the life is always a trade-off between one over other. Similarly in engineering, you have one variable is trading off with another. We have to maximize profit, minimize cost under various constraints. So when the constraints are loosely defined, they are called as unconstrained optimization problem. And when the constraints are very strictly defined, that is called as constrained optimization. So we will be seeing the various unconstrained and constrained optimization using software and the packages. So this is how this course intends to empower you, not to get intimidated, not to get fearful when you look upon the mathematical equations. In fact, the idea here is that you will love mathematical equations, although because you are learning this in the first year of your graduation, you may not exactly know how to form the mathematical equation. But here in this course, we are going to ensure that you will solve the mathematical equation. How to form the mathematical equation you will be learning in your subsequent courses, like how to form a heat transfer equation you will learn in subject heat transfer, other equations in fluid mechanics, transport phenomena, reaction engineering with respect to chemical. Similarly, for other engineering streams, you will be learning all those things in your different subjects. But end of it, you will have a system of equations which you should be able to solve. So this course looks forward empowering you with solving those equations. My favorite example, you may not know how to make pizza, but you know how to eat pizza. Similarly, this course will not teach you how to form equations, which you will be learning more in your engineering or sciences subjects, but this course will surely teach you how to solve those equations when the equations are in front of you. You will surely eat that pizza. So concluding here, signing off, Professor Dr. Makarand Upkare, thank you very much.